In the second part, we will be talking about the maintenance of body temperature during exercise. To do so, we will investigate it in three matters. The first of which, we'll be talking about how much heat we have to deal with in terms of maintaining the body temperature. Secondly, we'll be talking about how the hypothalamus is the body's thermostat. And thirdly, the body's response. During strenuous exercise, the body's heat production may exceed 1,000 watts, an increase of 10 to 20-fold. Heat starts to accumulate in the body when the heat-dissipating mechanisms are unable to cope with metabolic heat production. The duration and intensity of exercise, which drives metabolic heat production, contribute significantly to the amount of heat accumulated in the body during exercise. 70% of metabolic heat generated has to be transported from the peripheral compartments of the body to the skin to be dissipated to the environment. 30% of the heat generated is converted to mechanical energy. Some of the heat produced is stored, raising body core temperature by a few degrees. Rises in body temperature are sensed by central and skin thermoreceptors, and this sensory information is processed by the hypothalamus to trigger appropriate effector responses. Other sensory inputs from baroreceptors and osmoreceptors can modify these responses. In humans, body temperature is regulated at the hypothalamus, as explained before. This is a region of the brain. It regulates the body temperature to function within 1 plus or minus 1 degree Celsius of resting temperature over each 24-hour cycle. Deviation from resting body temperature affects various physiological systems in the body, which is indicative of the span of biological functions and dysfunctions that interact with the thermoregulatory mechanisms. Evaporation of sweat and increased skin blood flow are effective mechanisms for the dissipation of heat from the body, but dehydration impairs the capacity to sweat and lose body heat. Evaporative heat loss takes place when sweat changes from liquid to gaseous states. During physical exercise, more than 80% of heat is dissipated through evaporative heat loss, making it the primary means of heat removal from the body. About 1 liter of sweat is lost for each hour of exercise in hot conditions. Hot, humid environments or inappropriate clothing may compromise the ability to lose heat from the body. Hyperthermia may also function as the signal that triggers the central fatigue response during intense exercise. The occurrence of central fatigue at a threshold temperature may serve to protect the body from overheating by forcing exercise cessation so as to prevent further increase in body temperature. Hypothermia may therefore serve as a self-limiting signal to the central nervous system to protect the body against lethal heat stress. Once the metabolic heat is transferred to the skin, there are various ways in which it can be lost to the surrounding environment, including radiation and conduction. Radiation is a loss or gain of heat in the form of infrared heat rays. All objects that are not at absolute zero temperature emit such rays. The human body simultaneously emits and receives radiant heat. When the body temperature is higher than that of its surrounding, a greater quantity of heat radiates from the body than to it. The transfer of heat from a body to an object, or vice versa, or within an organism down a thermal gradient is called conduction. In this case, an athlete exercising may be making contact with an object of different temperature. For example, a runner could be running on a cold road, thus leading to conduction and eventual cooling down. To summarize this part, we know that exercise is associated with an increase in body core temperature. We therefore need to lower this body core temperature to avoid the risk of organ failure. The lowering of body core temperature can be done through various mechanisms. The first one we talked about was perspiration. The second we talked about was the central fatigue response, and the third, conduction and radiation.
Created using Powtoon.